Hi, good day. My name is Shania Victor, and today I will be presenting on the topic amylose. So, what exactly is amylose? Well, amylose is a linear polymer of D-glucose units, which constitutes about 10% to 30% of starch. To expand, amylose is indeed a polysaccharide, which is formed from linkages of alpha D glucose units bonded to each other by alpha 1 to 4 glycosidic bonds. So just to sort of put things into perspective, I'm just going to share my screen really quickly so we can both look at the structure of animals that I previously drew. Okay, so here we are. For the sake of time, I just went ahead and drew what we see here. So a couple of things to point out. Don't be fooled. Amylose isn't just composed of two glucose units. In fact, it can contain up to several hundred glucose units, anywhere from about 200 to even 1,000, which, by the way, are made up of aldehyde functional groups. Another thing we want to look at is this guy right here. Now, we said before that amylose is composed of alpha D glucose units. So what does that mean? This simply means that the OH group here is below the ring, hence alpha, and it is D, considered D, because it is on the right side of the structure. Moving on. So you may be wondering, how exactly are these two singular glucose units combine to form amylose? Again, we're just using two for the sake of having a reference. Well, first of all, polysaccharides, which is what an amylose is, are formed when dehydration reaction occurs between a large number of monosaccharides. So the dehydration reaction, aka condensation, if you prefer to use that term, is a conversion that involves the loss of water from the reacting molecule or ion. So with that being said, we're just going to display that here. In order for these two to combine, we have to remove water. So we're removing H2O, leaving behind oxygen. Okay, so we're just going to erase that now. So we'll redraw the oxygen. Okay, so now we can place the oxygen back into the center here, make things a little easier. And we're going to connect each of these structures here to the oxygen. And that is how we form our 1 to 4 glycosidic. Which, by the way, let's just number it really quick. We have 1, 2, 3, 4, 5 at the bottom, 6 at the top, and vice versa here on this side. In addition, we're going to want to remove the hydrogen from either side of these units here, seeing as they would form other glycosidic bonds. There we go. For the sake of appearances, just going to redraw the oxygen here on the sides. And there we have it, our structure of amylose, our 1 to 4 glycosidic bond, alpha glycosidic bond. I'm just going to stop sharing the screen. Now that we're back, just to end off, we're just going to list a couple functions of amylose. What exactly is their purpose? Well, they have several. They can act as a gelling agent, a water binding agent, a thickening agent in foods, and even as a plant energy store. So a lot going on. Thank you so much for your undivided attention. I really hope that you learned something from my amylose presentation. Thank you.